Okay, next flipped lesson for Common Core Algebra 2. This is going to be on 3.5 matrix operations. So we're going to get a little bit out of order here. We're going to skip 3.4, do 3.5, then come back to 3.4. I think that order is going to work a little bit better for us. So first thing, we will introduce what a matrix is, which is probably something new to you. And then we'll talk about how we add and subtract matrices and what something, how we multiply something called scalar multiplication, which is different than multiplying two matrices together. And you'll see that in a minute. So first thing, some new vocabulary for us. A matrix is just going to be a rectangular arrangement of numbers. They're going to be situated into rows and columns. When we talk about the dimensions of a matrix, that's going to be listed as rows by columns. So if it's got 3 rows and 3 columns, it would be a 3 by 3, and that we would say that's its dimensions. And that's going to be very important, especially when we talk about adding and subtracting matrices, and also when we talk in our lesson for 3.6 about multiplying matrices. Okay, the elements then are the numbers that are in the matrix. So each matrix has X amount of elements. If it has dimensions 3 by 3, 3 times 3 would give us 9 elements. If it was a 2 by 3, it would have 6 elements. Each one of those being listed as a separate number. Okay, in order to add and subtract matrices, what we're going to do is combine, so add or subtract, combine whether depending on which operation we're talking about, and we're going to combine those terms that are in the corresponding positions. So your first element with your first element in your second matrices, your last element with your last element in your other matrices. So what's really important is this is only possible when the dimensions are the same. So they're both a 3 by 3 matrix, or they're both a 5 by 2 matrix. Whatever it is, they have to be the same in order to combine them. Okay, a couple examples of that if we combine these matrices. So you see here we are adding, which means I'm going to create another 2 by 2 matrix. So you see this one is 2 by 2, meaning 2 rows by 2 columns, and then this one is also a 2 by 2. So since our dimensions here are the same, we can combine them. So I'm going to say first row, first column 3 with the first row, first column, and the other one, that's 3 plus negative 1 gives us 2. I say 0 plus 4 gives us 4. Negative 5 plus 2 gives us negative 3, and negative 1 plus 0 gives us a negative 1. Okay, if this was a subtraction symbol, we just do the same thing, but with subtraction. 3 minus negative 1, 0 minus 4, negative 5 minus 2, anything like that. So this would be our resulting matrix, and again, that would be a 2 by 2. So anytime we add or subtract two matrices, the dimension should stay the same. Looking at this one, you see here again we have a 2 by 2 to start, but now we have 2 rows but only 1 column. Since their dimensions aren't the same, we cannot combine here. Okay, again, the dimensions have to be identical. Okay, then we're going to have something called scalar multiplication. Scalar multiplication just means that we're multiplying a matrix by a constant or a variable. And in order to perform this, you just want to think of it as distribution. So we're just going to distribute the scalar to each element. So we're going to multiply whatever our scalar is times each element. Okay, in this case, our scalar is negative 2. So we are going to distribute that negative 2, just multiply. Negative 2 times negative 7 gives us 14, negative 2 times 11 gives us a negative 22, negative 2 times 5 gives us a negative 10, and negative 2 times 0 stays as 0. Okay, and that is it for scalar multiplication. It's really just distributing. So we just took negative 2 times each piece, and that gave us our resulting matrix. Again, this is going to be a 2 by 2. So we've seen a lot of 2 by 2s in this lesson. By no means does that mean that all we're going to look at. Okay, so two big things: adding and subtracting matrices. You just combine your corresponding terms, so terms that are in the same position. And then our scalar multiplication is really just distribution. All right, see you next time.